Aerial transportation brings up the concept of global village to its best. People and cargo can now travel anywhere in a matter of hours, so it becomes an area of major importance to the European Union today. In ways to turn the aerial transportation more efficient appears the CROP project, which is a new way of propulsion, a cheaper and environment-friendly one. The project is led by UBI, among with several European partners, the University of Sheffield, the University of Modena and Reggio Emilia, the University of Bologna, and two companies, the Austrian EAT21 and the German Grob Aerocraft. The project will occur for the next 2 years and will be led by the Professor José Pasqua of UBI. The public presentation of the CROP project had happened in UBI at the 21st of January 2013, with the Vice President of the University, Professor Ana Paula, the President of Engineering College, Mario Freire, and the President of the Department of Engineering Electromechanics, Professor Abílio Silva. The concept of cyclorotor gets its name to the cyclodal trajectory that the shelves get in the air during the flight. These systems get the ability to change direction of the propulsive force in 360 degrees in ways almost immediately, which allow the vehicles to take off vertically.
For Europe, we have to look in the worldwide world that is full of competition among partners. In this regard, most of European industry, even in aeronautics, is being dismissed because competitors from China and from Brazil and America, from other parts of the world, are becoming increasingly strong. So I think it is a good idea that the European Commission decided to fund this project because it can help strengthen the European position regarding this kind of industry. UBI is actually the promoter of CROP project. We have been analyzing cycloidal rotors and the electrical rear discharge actuators, and our idea was to keep together with all the European partners that are working in this kind of activities, and for this regard we can have more support for the current research activities here in UBI in Portugal. These cycloidal rotors is actually a concept that has only been working for, let's say, ships. That is called the Voigt-Schneider propeller, but it is envisaged that with this concept we can also be applied. It can also be applied to, for example, vertical axis wind turbines for production of energy. So it actually can span a bit to other areas of the research.
I think it's very important that our professors take this knowledge from this research and transfer to the students. It's very important in this sense.
We are in charge of the work package that takes care of simulation. So we are going to simulate the structure, the aerodynamics, and their interaction in order to provide feedback to the designers of components and to the manufacturers. Feedback in terms of structural loads, performances, and so on. Of course, we are in charge of this work package in cooperation with other partners.
It should be possible in the next 2 or max 3 years. It is possible to have a prototype operative prototype, not the mock-up. Okay, but. It is a very interesting project, but a limited object, so it should be possible in a very short time.
We are leading actually work package 7. It's about the dissemination exploitation of the CROP project, and will assist in many other tasks, for example, proof of concept and integration into aircraft structures.
About 2 years ago, I thought it would be about 25 years, and now I think it's going to be about 10. So we've advanced so much in the last 2 years with this project, or with the science behind cyclogyro, that I'm much more confident that as soon as we provide an unmanned vehicle that can be tested and proved to be safe, the move then to providing it as a passenger aircraft is more one of regulating the airspace to allow it.
I think there's a lot of applications around, you know, as well as transportation. When you look at the demands for surveillance from a climate point of view, from a weather point of view, you know, you have a lot of demand for aircraft that need to be very efficient, to have good manoeuvrability, to be able to stay stationary. And I think whether that's search and rescue, whether it's, you know, lots of applications you can see that even though they're not transport, will benefit from this kind of technology.
They can be scaled up to provide freight aircraft. So, for instance, FedEx could be using these things in swarms to deliver parcels and packages around the planet. They could be used for, we say, Rettungs vehicles. So they could be used for lifeboats off ships when you scale them up. When you scale them down, they could fly inside buildings and go and look in smoke-filled rooms for casualties during a fire. They could go monitoring radiation in somewhere like Fukushima, a nuclear power plant that has been engulfed by water. They could find out what the radiation levels are before human beings go in. They could be used by the United Nations to follow and help refugees so that they can see where there are minefields, provide light at night so that they feel safe from soldiers, tell them where to cross a river and so on.
Which led this technique searching the and then we go to the interpreter, which is the next experiment for search. Afterwards, we will go to the